So today we are going to see P&O based MPPT for DC to DC converter with a battery charging system. So to understand the MPPT for PV panel, I have created a 1 kilowatt solar panel, and also there are 5 converters I have created, and also a battery. So today we are going to see a P&O based MPPT for DC to DC converter for a buck converter. A buck converter based charging system. MPPT is nothing but a maximum power point. So there are several control algorithm is used to extract the maximum power from the PV panel. So namely Perturb and Observe based, then incremental conductance. Then there are several bio-inscribed algorithms, namely particle swarm optimization, Anne-Conley optimization, Anne-Lane optimization, Gray Wolf optimization, and then fuzzy GA. There are several algorithms is there. We will see all the algorithm for the MPPT one by one in next classes, and also we will see all the converter based MPPT for one by one next video itself. So today we are going to see P&O based MPPT for buck converter with a battery system. So to understand the maximum power point from the PV panel, we must understand what is P&O. P&O is nothing but what? Perturb and observe methodology. Is nothing but to extract the maximum power from the extract voltage. It is also known as a hill climbing method because it is climbing the power curve to reach the what? Maximum power point. There are two categories there are two steps involved. One is perturb and another one is what? Observe. Perturb is nothing but to introduce a small changes to the PV module, such as increasing the array operating voltages to cause its power to vary. So second one is the observe. Observe is nothing but periodically measure and compare the PV outputs power to the previous one. So here I have created a 1 kilowatt solar panel. It is a user defined functions. I have mentioned different irradiance level to extract the maximum power. So I have created a 1000 and also 800 and also 600 irradiance level. So these are the PV characters for different irradiance level. For the 1000 irradiance level, it reaches nearly 852.6 watts at the voltage of 58. This one is 1000 irradiance level. So second one's curve is 800 irradiance level. It nearly reaches 687.19 at the voltage of 58.38. Third one is a 600 irradiance level. It nearly reaches 518 point. So this is the point to extract the maximum power at the voltage points. Okay. So this one is the power curve. This one is current curve. It is my user defined function. So this one is a buck converter. So buck converter, it is a MOSFET based buck converter. Inputs are connected to the PV module. The outputs are connected to the battery charging system. So I have mentioned the battery voltage is equal to 48 volt, 200 amperes per hour, and also state of charge is equal to 45. Battery response nearly 1. I have used only a lead acid battery for my understanding the MPPT algorithms. So it is a P&O model. P&O is nothing but what? Perturb and observe. So there are two inputs used for the P&O chart of P&O. So initially is the parameters of PV panel. From the PV panel we measure the voltage and current. From the voltage and current we calculate the power. So if a changes in the power is greater than 0, it proceed to next step. Here if a changes voltage is greater than 0, once again if we move to new one values, it is a decremental method. If it is a less than 0, it's moved to incremental method. So similarly follow these steps. This is the P&O flow chart. Based on the flow chart, we have created a function here. So we will get the new values here. So based on the new values, we compare to the PWI pulses and generate the gate pulse. This gate pulses will give to the MOSFET of the buck converter. So here we have used the buck converter. So this is the input side. This input side is connected to the PV panel. This is the output side. Output is connected to the output side is connected to the battery. Okay. So here I have mentioned the different irradiance level. At 0 times I have mentioned 1000, that is in my maximum irradiance level. At 0.2 seconds I mentioned 800. Similarly 0.3 seconds I used here 0. So to understand the concept, I have measured all the PV power here and also the battery power here. So now I'm going to run the model. So at a different irradiance level we are going to extract the maximum power from the PV panel. So it is a PV power output here. Here battery power output. So this is a P&O algorithm. I have it will say here the 8 pulses generated. So we can see here the hill climbing method is nearly reaches the gradually increase the power curve to reach the maximum point. So I already mentioned it reaches 852.3 volt at the voltage of 58 volts. So we can see here the voltage is nearly gradually increasing from the what 819 to 824, 831, and it is reaches 852.3. This is the PV power. So this is only the battery power. You can see here the battery current is negative. That is mean by the battery is what charging. The battery is going to be what charging. We can see the simulation runtime nearly reaches what 0.0072 only. When it is reaches 0.2 second, the irradiance level will be 800. So for this irradiance level, it will be goes to the what second point, and that is the second maximum power point. If now it is currently running what 1000. So 1000 irradiance level, we can see here it reaches what maximum power 852.3 watts. Is that clear?
The P&O based MPPT is working properly. So we can observe that when it reaches to 600 irradiance level, we can see here when it reaches what 600 irradiance level, obviously the power reaches what 652 point from the. So you can see here the P panel when it reaches 600 irradiance levels, it reaches over around what 687.192 watts. So see here when it reaches 600 irradiance level from the time between 0.2 to 0.3 seconds, it's nearly reaches what 687.12, and from the time period of 0 to 0.3 to 1 second, the irradiance level is what 0. So obviously the panel of the PV tends to what 0 voltage. So there will be no power. So therefore we are getting what 0 watts. So during the interval period between 0.3 to 1 seconds, we can see the battery. The battery power reaches what? The battery power reaches what? 0. The reason beyond that, when the PV panel is getting the maximum power, the battery is what? Charging between the period of what? 0 to 0.3 seconds. When irradiance levels reaches 0, obviously the battery also goes to what? Not charging. At this time onwards, the battery is what? Is ready to discharging the power. So here we are only using what? To charging the battery. Okay, is that clear? Then after that the time period of 1 to 2 seconds, the irradiance level is what? 1000. So therefore we are getting the what? Maximum power is nearly what? 851.7 volt. 851.7 watts. So here we are getting the what? Maximum power for the battery at the irradiance level of what? 1000. So our designed MPPT for P&O based MPPT is working what? Properly for the buck converter with a 1 kilowatt solar panel. So I have designed all the 5 converters, boost converters based MPPT, and also SEPI converter, Zeta converter, CUC converter. All the converters are used to integrate to the what? Battery system. If you have any doubt on this simulation regarding, you contact me in this number or this mail ID. Okay, thank you all. We will see all the converter based battery charging in next videos. Thank you.